I'm glad here to share our work, the Eye of Sauron. So this term is come from the Lord of the Rings. If you still remember the thing in the model, there is a big eye. So if anyone wears the rings, the eye will tracking the person, no matter where they are and how long it is. Okay, so but our work is good, not an evil one. We are trying to localize the spy cameras. So when we mention the spy cameras, that is a big concern right now because if we go to the hotel or the Airbnb, if the room have the spy cameras, that is very horrible. And even today, the camera can be manufactured very small, and also they can be digested in the like the smoke detector or the USB. Right? So we have heard a lot of reports about the concern of this such threat. And also, even in our home, there are a lot of cameras recent days, right? For my own experience, we have 4 Amazon Rings cameras in my home for monitor the driveways, the surroundings for security. My wife always persuades me to install more, like monitor the oven. So whether we leave home, we still turn on the oven. We forgot to close it. But I say, no, there are some security issues here. So, so let's see for the spy cameras, right? So what kind of method, existing method could detect those cameras? There are several ways because we know for cameras, what we have, there is a lens. They are made by the glasses, right? We all know that the glasses can reflect lights more than other things, materials, right? So basically what we can do is we can detect whether there are some glasses, like in the smoke detectors. It should not be there are glasses in the smoke detector. We can put some lights towards the smoke detector to detect whether there are more lights reflected than normal. And also, we can use some wireless things, like try to measure the time of flights to measure the length. But the problem is it requires low and sweeping to the entire space, right? And also suppose there are a lot of fake reflectors, like the window, like the table surface, right? So that makes the false positive high. And then the other thing is we can, several cameras, spy cameras, they are connected to the internet with wireless transmission. So basically we can monitor the wireless channels to detect those spy cameras. But the thing is not all the spy cameras transmit their data with wireless channels. And also even for the wireless cameras, they can still store the data locally and transmit those data back when the users leave the space, right? And so such existing works cannot fully address the concerns. So the problem is here is, because the spy cameras in different forms, we can use wire connected and also the Wi-Fi connected, or even just store the data locally, right? So that is the basic thing existing work cannot fully address. And also, the other thing the existing work does not address is we cannot localize them. We can only know, okay, there are some spy cameras in the room, but we do not know where they are. So we need a localization method to localize them very quickly. And so the question here is, can we basically develop a long-range detection, because we do not hope to take too much time to detect, to walk all around the room to detect the spy cameras and find those cameras. Okay, so but for the system design, the long range also brings another thing, right? So for example, if in the room we have 5 spy cameras, because the thing is our system is long range, perhaps we can detect all the cameras at the same time. So we need to dealing with collision problems, okay? So that is the trade-off of the design. So let's first introduce the observations of our work. What's the magic we leverage to detect the spy cameras? So what we leverage is from the memory. Okay, so actually, if you look at the structure of current camera, so we have the sensor to sense the thing, and then it will digitalize to the memory. And actually, the MCU, which is a computation module, is extract the video from the memory and do the processing and do the coding, and then transmit those coded data to the users or the malicious guys. Okay, so for the memory, so if you look at the red figure, okay, so there are some capacitors. So the capacitors is the transistors. Okay, change the status, change the electronic status of those capacitors. So when the status change, okay, so they will emit the electromagnetic radiations. So according to these radiations, we can detect whether the memory is changed. So in this way, basically, no matter the signal, the data is transmitted through the wired connection or wireless connection or directly stored in the local memory, we still can detect those we call this electronic magnetic emissions. Okay, so yeah, this is what we call the EMR. Okay, this is kind of this is not, the signal is not like a pulse, but it's kind of spikes spreading across a spectrum. Okay, so this is actually determined by the clock strategy, modulation strategy used in the current cameras. Just because if we just use a sine wave clock, okay, then the emission will be concentrated in a narrow frequency. That is, power is super large, which is not allowed by the wireless society. So they just do some modulations on the clock and make the EMR spread in the spectrum. Okay, and then what our observation is, if we change the thing, okay, so basically the camera will do some storage in its local memory, then will cause the change of the EMR. When we detect the EMR, we can detect the spy cameras. Okay, so then this is an overview of our design framework. You can see, first of all, we have a prototype of our system. And then what we are doing is we first detect the EMR. And the first thing, as I said, because the EMR enables a long-range detection, right? So, but the problem is if there are tens of cameras, or we still can have in the room, we still can have our smartphone, we can have our laptop. All of this has memory. Okay, all those kind of memory will emit the electromagnetic waves. So how we distinguish all of this? So the first thing is we develop the algorithm to distinguish which is from the spy camera and which is from other noisy part. Okay, and then because if the range is long, for example, the spy camera is far from here, and then the received signal is relatively weak. So how to leverage those weak signals to do the positioning is a quite challenging thing. So to bridge this gap, the first thing is we increase the signal strength. So then we propose a folding algorithm to increase the signal strength. And then based on those increased signal power, we can leverage develop a positioning algorithm to get us to find those spy cameras. Okay, so basically this system consists of 3 challenges. The first is what kind of characteristics we can leverage to distinguish different cameras in this room. Even though we may think the spy cameras, maybe the malicious guys just use the same brand, even the same module, okay? Can we just distinguish them clearly, okay? If we still have tens or even 20 or 30, can we distinguish them very well? What kind of characters we could leverage to distinguish them? And also for the increase signal strength, how we increase the signal strength, and then how to do the positioning, the last challenge. So you can see based on the clock modulation, as I mentioned before, so we have several characteristics we can use, like the F0, delta F, and FM, okay? So we call the statistic characters. And also when we know when we do the memory access, it will generate heat. The heat will make the clock shift. So the shift pattern is quite dynamic across different cameras, even though they all have the same brand. So that's what we call the dynamic patterns we can leverage to distinguish the different cameras. And you can see the figure here is the specs indicate the EMR signal, and they are periodically appear. And then because the spike is periodically appear, so we just can do the folding, which means the noise is randomly appeared, okay? Even though some specs are overwhelmed by some noises, okay? But not all of them were overwhelmed. So we can do the folding to increase the signal strength, okay? And then we also, there are some situations that if the thing is quite static, there is not too much change, then the memory access is small, then how we could increase EMR. So the basic idea is we can do some stimulus, just turn on the light or just do some change of the thing. So that can increase the EMR as shown in the top figure, okay? So for the positioning, just we can build a coordinate with our body, and we hold the antenna through the left to right, to top to down, and back to back. And then according to the folding as received signal strength, we can know basically where the cameras could be, and then we walk toward that direction, and then we do this again until we find this spy camera. Okay, so this is basically our design. And then we do extensive evaluations for our system. Our prototype have a computer for processing and USRP for obtain the raw signal and the antenna, and also use light to do the stimulus. And we test a lot of cameras, include very tiny spy cameras, the security camera in our home, and a lot of cameras. And in different scenarios includes hotel, bathroom, office, and conference. And here are some results here. So let's see. So for this one, right? So for the left corner one, okay. So with multiple stimulus round, okay. In all the scenarios, we can find the spy camera very efficiently. And also this is, say, with the increase of the number of the devices, we still can achieve high accuracy to detect all of those cameras. And also for the speed to detect the different cameras, okay, we can spend only a few seconds to find all the cameras. And also for the different style of the memory with DDR2 or DDR3, okay, we have high performance also. And also for the layers, for if we bury the cameras in the wall or behind a mirror, we can still find that one. And here are some localization efficiencies, like how we localize them in half minutes, and also how much distance we should walk to the camera needed. Okay, so basically the system is quite efficient. Okay, so here we just to conclude, we propose a system, okay, to find the spec cameras. We leverage the EMR from the cameras. No matter it is wired or wireless cameras, this system works well. And we also did some experiments to show their efficiency, okay. So that's all, thanks. Questions are welcome.